Welcome to the Crazy Hat Chemist. So another video here on equilibrium. In fact, it's the last video of this unit. Bam! So today we are talking about equilibrium calculation number 6, which is an isomerization of N-butane to isobutane and back and forth between isobutane to N-butane. But before we get started, don't forget that at the end of this video here, I'm going to have a chemistry joke. Gotta wait for that. Okay, and then 2, a little helpful hint on solving problems in chemistry. All right, so that's going to be at the end of this video here. All right, so let's get moving on with this problem here. Here is butane. So that's C4H10, gaseous state is N-butane. C4H10, gaseous state is isobutane. And you're thinking, wait, Mr. Moprion, you made a mistake. No, I didn't. Okay, those are the correct formulas. Okay, and one is butane, one is isobutane. And here are the structures. N-butane is just this nice chain, and isobutane has one of the groups, the methyl group, removed and stuck in the middle of it. So it's an iso group. Okay, all right. So here's the Keq, that is products over reactants with the stoichiometric coefficients as exponents. I got coefficient exponents as ones here. Okay, the product is the isobutane, that's why it's in the numerator, then the N-butane is in the denominator. And that's 2.5 to 1, which is equal to 2.5. So the Keq is 2.5. Notice that the Keq here is greater than 1, therefore this is a product-favored reaction. So this normally is at this temperature, whatever it is, goes towards products, goes towards the isobutane. All right. So I want to show you graphically what this actually means. So I got isobutane on the y-axis and N-butane on the x-axis in terms of molarity. And I've drawn a line on this graph here and shaded it in so you can see it readily. On this line right here is when the Q is equal to the K. So that means there are truly an infinite number of values when the Q equals K. That means I have to get 2.5 to equal the K. All right, so there's an infinite number of values that give me the value of 2.5. 2.5 to 1 is just about one of them, right? 5 over 2 is one of them. Okay, so there's a variety of different ways of which you can get 2.5 from the isobutane and N-butane concentrations. Truly an infinite number of them. And that's why this is a solid line. Okay, anything above this line is when the Q is greater than the K, and of course when they are not equal, then you are not at equilibrium. Okay, and then there's a shift that needs to occur such that the shift needs to have the Q approach the K and the Q needs to get smaller. If, however, you are below this line, that means that the Q is less than the K, and again, you are not at equilibrium since you are not on that line. But the Q needs to approach the K. Therefore, the Q needs to get larger. All right? Hopefully that makes sense for you. It's a great graphic, I think. Really points out the fact that there are an infinite number of values, numeric values in the numerator and denominator that will give me the 2.5 of the equilibrium constant. All right, so this is truly a balancing act. I love that ballerina right there because she is balancing and she is attaining new equilibrium positions by moving her head, her chest, her arms, her legs in different ways, shifting her weight so that she attains a new equilibrium, which is what Le Chatelier's principle is all about. Okay, a stress on an equilibrium system will acquire a new set of equilibrium conditions. Okay, all right. So let's try another problem here. Equilibrium is established when the iso concentration is 1.25 molar and the butane concentration is 0.5 molar. Okay, then suddenly you're going to add 1.5 molar of butane is added to this equilibrium system. So when the system comes to equilibrium again, what are the new iso and butane concentrations with the new shift and change? So here's my equilibrium equation. I'm going to do an ice table like I always have done with all these equilibrium problems. Now this is a very unusual problem in that I do have something on the product side. Okay, I have something on the reactant side and I do have something on the product side. So here's kind of how it is. I have initially the N-butane at 0.5 and the iso at 1.25. That is a value of 2.0, which is the equilibrium constant. Okay, but you're going to suddenly add more of one of them, and it just happens to be the N-butane that you're going to add to this. So this is going to cause a shift. This shift is going to decrease the reactants and increase the products. Decrease the reactants, increase the products. I have stoichiometric coefficients of a 1. I'm going to add up my initial and my change, just like that. So I got 2 minus x, and I got 1.25 plus x. Now I need to get the Keq expression, products over reactants, stoichiometric coefficients as exponents. We actually already wrote it down on the previous slide, but it is right here, and I do know that it is at 2.5 at equilibrium. So I need to plug in these values and solve for what x is going to be equal to. So I got 1.25 for the isobutane in the numerator plus x, and in the N-butane I got 2.0 minus x in the N-butane in the denominator, and that's equal to 2.5. So I'm going to solve this mathematically for x. I'm multiplying, cross-multiplying, if you will, right here. Now I need to distribute that 2.5 over the 2 and the minus x. Now I'm going to bring all my x terms to one side and my non-x terms to the other side. Now I'm going to divide by the coefficient in front of the x on both sides. And then that will give me a value of what x is equal to. That's 1.07. Now 1.07 is not any of the concentrations. What I do have to do now is plug this back into the equilibrium values. And I have the butane at 2.00 minus x and the isobutane at 1.25 plus x. So let's plug those in. Okay, so for the isobutane, I got 1.25 plus x, which is 1.05, and I get a new concentration of 2.32 molar. Then for the N-butane concentration, I'm going to take the 2.00 minus the 1.07, which was x, and I get 0.93 molar. So those are my new concentrations at a new equilibrium establishment, if you will. So does that really hold true? And I've mentioned this multiple times within different problems, but here I'm going to show you physically how we're going to check it. So I'm going to check this by plugging these values back in. So I'm going to plug in the value of 2.32 in for isobutane and the value of 0.93 in for N-butane. Okay, that's what I've done right there. What number do I get? 2.5. Does that make sense? Well, of course it does, because you should see that that has been a new equilibrium has been established, and now I am at the same K value that I had before, which is the equilibrium constant. That is perfect. Okay, I'm not done yet. Okay, so you are going to whip chemistry, and this is your little hint on how to solve mathematical problems in any chemistry problem. It doesn't need to be this particular unit. So whip is what is the problem asking. So you first need to ask yourself, what is the problem asking? Then the H of the whip is how to begin. So how do you begin the problem mathematically? Okay, then the I is what information is needed. What information is given, what information is needed. And then finally, proceed step by step without skipping any steps. And how I remember this is, I remember this group, and this group is Devo, and they have this great song, Whip It. Whip it. Okay, so don't forget about whip. Okay, and then I got a chemistry joke for you. Okay, and here we go for our chemistry joke. Old chemists never die. They just reach equilibrium. Hopefully you enjoyed that. I am the Crazy Hat Chemist, and I am wearing my brand new bicycle helmet. So, just a little plug on bicycling. I'm an avid cyclist. So make sure you wear your helmet, make sure you have the front in the front, the back in the back. You strap the clip right over here, you tied it in the back. Okay, wear your helmet every single time that you go cycling. Okay, because you need to protect what's inside your head so that you can do these chemistry problems. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Pass on my YouTube channel to all your favorite friends and relatives. Please subscribe. Look online and find my website as well. Thank you very much. Bye now.